First, let us go through the most basic but most fundamental part of circular motion, the radian. The radian is somewhat like the degree. It's a unit of angular measure, but based on the radius of the circle. It's way more useful, which you'll realize in later lectures. Well, consider the following unit circle. When we trace out an arc of length 1, the angle which is subtended by this arc is 1 radian. Hence, 180 degrees corresponds to pi radians, and 360 degrees corresponds to 2 pi radians. Furthermore, 2 pi radians corresponds to a full circle being traced out. How about a little brain teaser for you? Now, how many radians does 45 degrees correspond to? Well, considering that 180 degrees is pi radians and 45 is a quarter of 180, the answer is pi over 4. Woohoo! So what's so important about this concept? Radians are able to do the things that degrees can't. For example, when you differentiate a quantity with respect to an angle, this angle must be in terms of radians. And we will look at this further in the video on quantities. Another example is the small angle approximation, which we will be using in due time. When an angle is really small, the sine or tangent of that angle can be assumed to be equal, with negligible error, to the value of the angle itself measured in, guess what? Radians! These properties of the radian are extremely important for this topic. So stay tuned.